Roads are no longer just paths for vehicles to travel on. They've evolved into intricate systems brimming with technology and innovation. From intelligent traffic management to roads that generate clean energy, these smart road infrastructures are revolutionizing the way we travel the world. Join me for today's video. I'm counting down the top 15 smart road infrastructures. Number 15. The Hong Kong-Zhuhai-Macau Bridge. Built between 2009 and 2018, the Hong Kong-Zhuhai-Macau Bridge, which is also known as the HCMB, is probably the most advanced road bridge in the world. For a long time, it was surprisingly complicated to travel between Chinese mainland and both Hong Kong and Macau, and this project was conceived to make things much simpler. At 34 miles or 55 kilometers long, it's made up of a series of bridges, tunnels, and artificial islands that cross the Pearl River Delta, and since opening, it shortened travel times from several hours to just 45 minutes. The main bridge itself stretches for 18.4 miles or 29.6 kilometers, and it's currently the world's longest sea-crossing bridge. Just this part of the development is believed to have cost upwards of $7.5 billion to complete, with the entire thing estimated to have cost around $18.8 billion. One of the reasons it was so expensive is because of some of the unpredictable weather conditions in the region, particularly the strong winds that can develop during a typhoon. And of course, the bridge needs to be able to withstand these and ensure the road users are safe too. The other thing about the bridge that's unusual is that despite driving on the left-hand side in Hong Kong and Macau, the HCMB is classified in Zhuhai where traffic drives on the right. So before going onto or off the bridge, special viaducts are used to put drivers into the correct lanes. Number 14. Connected Vehicle Testbed, Michigan. The development of self-driving cars is the next big revolution in personal transport, but companies can't simply build them and let them onto the roads. Extensive testing needs to be done to ensure the technology allows for vehicles to communicate with one another so they're safer and more efficient. And the Connected Vehicle Testbed is a dedicated space where this can be done. Located in southeast Michigan, it's a hub for researching, development, and testing connected vehicle tech. At the heart of it is the city of Ann Arbor, which now leads the way in this technology after the implementation of the Connected Vehicle Test Environment Project. Set up in partnership with the University of Michigan Transportation Research Institute, it's seen over 9,000 connected vehicles equipped with advanced sensors and communication systems being deployed on the roads. These vehicles, including cars, buses, motorcycles, and trucks, can exchange real-time data with each other and infrastructure elements, such as traffic signals and road signs. The testbed's main objectives are to improve road safety, reduce traffic congestion, and to enhance overall transportation efficiency. And through this vehicle-to-vehicle and vehicle-to-infrastructure communication, it enables vehicles to talk to each other. Researchers and engineers in Michigan continue to use this testbed to develop and refine various applications, including adaptive cruise control, collision avoidance systems, and traffic signal prioritization for emergency vehicles, most of which will, because of the testbed, be coming to roads near you soon. Number 13. Egnatia Odos, Greece. Egnatia Odos, which is also known as the Egnatia Highway, is a huge infrastructure project that stretches across northern Greece, connecting the country's western and eastern regions. It's a modern, multi-lane highway that's been credited with significantly enhancing the country's transportation network by promoting economic development across previously underserved regions and by improving connections with neighboring countries. Stretching more than 416 miles, it starts in a port city on the Ionian Sea in the west and extends to the Aegean Sea in the east. In doing so, it crosses a wide range of landscapes, from rugged mountains to open plains, which made it a huge engineering challenge that involved the construction of 76 tunnels, 1,600 bridges, and a series of viaducts. The enormous undertaking began in 1994 and was finally completed by 2009 at an estimated cost of around $8.2 billion. Along with providing this vital east-to-west route, part of which follow an ancient Roman road, the route was designed to intersect with 9 highways that run north to south, that connect with countries like Albania, North Macedonia, Bulgaria, and Turkey, making it not only a vital transportation route through Greece, but one that's connected a much wider region of Europe. It's proof of how a well-designed road infrastructure plan can travel across a country without the need for sprawling individual projects, and it's now used as an example for other countries looking at upgrading their own highway networks in the coming years. Number 12. Nouvelle Route du Littoral, Réunion. The Nouvelle Route du Littoral, often referred to as the NRL, is a major infrastructure project located on the French overseas territory of Réunion Island, that's deep within the Indian Ocean. As with many other islands in that region, it's hilly and mountainous, which poses a challenge of the construction of roads, not just because of the uneven surface, but the ever-present risk of landslides. Its previous coastal road was notorious for delays and accidents, so the decision was made to build a new 7.5-mile-long elevated coastal highway that includes a series of viaducts and tunnels. Construction on the route began in 2015, and while it wasn't fully finished, it was first opened to vehicles in 2022, costing by that time around $2 billion, making it one of the more expensive stretches of road. A part of this is the offshore viaduct, which itself is the longest kind in the world, stretching over 3 miles of elevated roadway that connects the city of La Possession and Saint-Denis, and allows for smoother and more reliable travel between the island's major population centers. This wouldn't have been possible without modern-day design techniques and new ideas that were also incorporated to add environmentally friendly components, such as a sustainable drainage system. When it's finally complete, the NRL is expected to be used by 60,000 vehicles per day, providing them with a quicker, more efficient way to travel between the two major cities on the island, and removing this traffic from elsewhere that'll relieve daily congestion from countless smaller communities too. Number 11. The Great Belt Fixed Link, Denmark. The Great Belt Fixed Link is a vast infrastructure project in Denmark that connects the islands of Zealand and Funen. Previously, travel between the two was only possible by boat, but there was a clear need and demand for a fixed link. At the time, around 8,000 cars were traveling per day, but since the project's been completed, this average has now increased to more than 30,000 per day. Made up of a series of bridges and tunnels, the main parts of the Great Belt Fixed Link are the 4.2-mile-long East Bridge, which is a suspension bridge covering the eastern part of the Great Belt Strait, the 5-mile East Tunnel that was dug beneath the seabed, and the 4.1-mile West Bridge, which is a cable-stayed bridge. It took 10 years of construction before the fixed link was ready to open in 1998, at which time it had a 4-lane highway and a railway line. As well as being easier, it's also significantly cut travel times, with a ferry taking an hour to do a distance you can now complete in just 10 minutes. It's been by far the biggest and most expensive infrastructure project in Denmark's history, but one that's proven to be a major success and seen the local economy rapidly expand ever since. Number 10. Jebel Hafit Mountain Road, United Arab Emirates. Completed in 1980, the Jebel Hafit Mountain Road is a spectacular mountain road in the United Arab Emirates that, as it winds its way up the Jebel Hafit Mountain, offers travelers with incredible driving experiences and some of the most breathtaking views in that region. With a length of 7.3 miles, it covers some of the trickiest terrain to build roads on, and relied on a series of modern engineering techniques to even be possible. At its peak, it climbs to a height of 4,000 feet above sea level, making it the highest paved road in the UAE. On the way up, there's a series of steep hairpin bends, sharp curves, and unbelievable twists, meaning you'll be on the edge of your seat for the entire ride. Of course, most roads like this around the world aren't paved, but the engineers were aiming to make it as smooth and as safe of a drive as possible. Creating a flat surface with altitude changes like this require the use of various different materials within the asphalt, but ones that would also be able to endure the temperature changes that the road is subjected to as well. In total, there are 60 turns, and the road has 3 lanes, 2 going uphill and 1 going down. The effort is well worth it though, because when you reach the top, you'll be treated with a panoramic view that stretches for miles in all directions. On a clear day, you can see the vast expanse of the desert, the Al Ain Oasis, and even the neighboring Sultanate of Oman. The sunrise and sunset views from this place are spectacular, making it a popular place to go for tourists or those looking for a thrilling drive. Number 9. Katy Freeway, Texas, United States. The Katy Freeway, officially known as Interstate 10 in Texas, connects Houston, Texas with several other cities in the region. Stretching approximately 41 miles, it's one of the widest and busiest freeways in the U.S., and it's been crucial in the economic and transport development of Texas. Getting its name from the city of Katy, which is a western suburb of Houston, where the freeway's western terminus is located. It runs eastward through the heart of Houston, passing through the downtown area before continuing beyond the city limits. The highway is the main transportation artery connecting Houston to San Antonio and points beyond, but the thing that stands out the most, of course, is just how wide it is. This wasn't always the case, and in the early 2000s, the city planners were facing a major problem. There were huge traffic issues in Houston and further out, which would have normally needed thousands of miles worth of extra roads to accommodate. A huge expansion project was put in place, which saw freeway being widened in some places with as many as 26 lanes in certain sections, including one set aside for high-occupancy vehicles. This was such a huge increase in capacity that once it was completed, everyone noticed a massive improvement in traffic levels. This wasn't just because of the capacity, as technology was also installed like advanced traffic management systems, dynamic message signs, and real-time traffic information, all of which enables drivers to make better decisions and keep vehicles moving. Of course, this was all done around 20 years ago, so the traffic levels have again built back up, but it's a good sign to other cities that sometimes the most effective way to deal with challenges like this is to expand the infrastructure that's already there instead of building something entirely new. Number 8. Atlantic Ocean Road, Norway. The Atlantic Ocean Road is a scenic highway located along the rugged coastline of Norway. The 5.2-mile route winds its way through the breathtaking natural landscape that's said to be one of the most beautiful road trips in the world. Connecting several small islands and skerries along the Norwegian Sea, the road features a series of stunning bridges, viaducts, and causeways, including the Storsteisundet Bridge with its dramatic and seemingly precarious curve, which is known as the Drunk Bridge because of the unusual appearance. If it seems familiar, that's probably because it's a popular location to film automobile advertisements, as the sweeping turns look spectacular on TV. But while drivers along the route may not think much of its construction while they take in the scenery, this was extremely difficult but a vital project to complete. Engineers had to overcome a series of natural challenges, such as unstable seabed that wasn't suitable to hold foundations, extremely harsh weather, and huge tidal variations. All of these made it tricky enough to build, but it also put extreme pressures on the road structure, so it had to be constructed in a way that it would be able to endure these without developing any issues. It took decades for a plan to finally be decided upon, and a further 10 years to complete the project, but once it opened in 1989, it transformed the region. It's a gateway to the area. It's not just there for a pleasurable drive, and it's a vital connection between communities along its route that were previously reliant on boats to travel to the mainland. In many ways, it's road infrastructure like this that has the biggest impact on people's lives than the main projects that are focused on, like huge highways, that mainly aim to ease the amount of traffic going from place to place. Moving on to number 7, Smart Tunnel, Malaysia. The Stormwater Management and Road Tunnel in Malaysia, which is known as the SMART for short, was an ingenious infrastructure project that aimed to tackle two very different problems: traffic congestion and flooding. Located in Kuala Lumpur, the capital city of the country, it's a dual-purpose tunnel that can function both as a vehicle tunnel and a storm water management system. During dry weather or normal traffic conditions, the tunnel is used as any other road tunnel, helping to alleviate traffic congestion by providing an alternate route for vehicles passing through the city center. However, when heavy rains happen, cars take other routes, and the tunnel can be transformed into a storm water diversion system. There are actually two tunnels within it, a motorway tunnel and a storm water tunnel, and they're used in various combinations depending on the circumstance. The stormwater management system is crucial in Kuala Lumpur, which experiences frequent and heavy rainfall. During storms, flood water is channeled into the tunnel's lower level, effectively diverting it away from the city streets and reducing the risk of flooding in low-lying areas. The system can hold a massive amount of water too, up to 460 million cubic feet, making it a vital flood control measure. The Smart Tunnel's design uses these massive floodgates at both ends to control the flow of this water, and there are 4 phases of operation. Phase 1 is when the tunnel is being used for traffic only, where vehicles travel through the upper tunnel. During Phase 2, which is enacted during a moderate storm, traffic is allowed to continue to pass through with the lower tunnel being opened for water. When things are more severe, though, Phase 3 sees all traffic being cleared from the tunnel first, just in case water levels rise higher. And in Phase 4, which happens during prolonged, severe storms, water will flow through the motorway tunnel too. Once the event is over, the motorway tunnel is pressure washed and then is typically reopened to traffic within 48 hours. It is truly a novel approach to water and traffic management that used one project to tackle 2 very different issues, and a great example of how infrastructure developments don't have to be built solely for one purpose. Number 6. Zhonghai Bridge, China. The Zhonghai Bridge, which is located in the eastern China Sea, is also known as the East Sea Grand Bridge, spans more than 20 miles, which makes it one of the longest cross-sea bridges in the world. Completed in 2005, it has served as a crucial link between mainland Shanghai and the offshore Yangshan Deepwater Port, and it's contributed significantly to the expansion and efficiency of Shanghai's port infrastructure. The bridge has a gentle S-shaped alignment that means that it bends with the current, a design element that minimizes potential impact on the marine ecosystem. It was constructed using a combination of box girders, cable stays, and an arch for the navigational span, utilizing a range of different engineering techniques. Its design considers high winds, strong currents, and corrosive seawater, enabling it to endure the often severe weather conditions in the East China Sea. The construction of the bridge took advantage of cutting-edge tech and the newest composite materials to ensure longevity and safety. Special anti-corrosion steel and high-performance concrete were used to resist the corrosive effects of seawater and marine air, and the installation of comprehensive monitoring systems means that the bridge's structural health is continually tracked. The bridge, though primarily an infrastructure project, has also sparked the development of offshore wind farms along its route. The experiment of using it as a foundation for wind power installation in the East China Sea has proven to be such a success that similar installations are now planned along other sea bridges in China as well. Number 5. The Thomas P. O'Neill Jr. Tunnel, Boston, United States. This tunnel, commonly referred to as the O'Neill Tunnel, is an underground highway system in Boston that plays a pivotal role in the city's infrastructure, serving as a solution to combat traffic congestion, enhancing accessibility to the downtown area, and improving the overall transportation network throughout the region. Named in honor of the late U.S. Speaker of the House, Thomas P. O'Neill Jr., it's one of the busiest tunnels in the United States. At 1.5 miles long, authorities had wanted to build the tunnel for a long time before construction finally began in 1995, and it was long overdue. Traffic was becoming a regular feature of daily life in the city, and it was only projected to get worse. The problem, though, is that building a tunnel like this beneath the city is a huge engineering challenge, one that required the design of an all-new tunneling machine to even be possible. Big Bertha, as it was called, was absolutely enormous, measuring 326 feet long and with a cutting diameter of 57.5 feet. The entire thing weighed 6,700 tons and cost $80 million to build, and was made at a factory in Japan before being disassembled, shipped, and then reassembled in Boston. It was an astonishing feat, and took almost 10 years to complete the tunnel, but once it had finished with its task, it was disassembled and scrapped, since no other project in the world required a tunnel anywhere near the size of what it creates. Since opening, the tunnel has proven to be a success, and the envy of many other cities around the world because of the through flow of traffic that it can accommodate. But while that may be impressive, it takes a lot to maintain a structure like this. Many millions of dollars are spent per year to plug leaks that continually appear in the superstructure. But that's a cost that's seen as worth it, since the tunnel itself is estimated to save $500 million a year in lost revenue that would have been caused by the traffic that it prevents. Number 4. The Millau Viaduct, France. The Millau Viaduct, located in southern France, is one of the most breathtaking and iconic bridges in the world, known for its elegant design and impressive scale. It spans the Tarn River Gorge near the town of Millau in the massive central region of France, and after being designed by the renowned French structural engineer Michel Virogu and architect Norman Foster, the bridge was completed in 2004 after 3 years. The viaduct measures an impressive 1.53 miles, which makes it one of the longest cable-stayed bridges in the world. Amazingly, its highest pier stands 1,125 feet high, which means it's even taller than the Eiffel Tower. In an example of how things can be functional but aesthetic too, the use of slender towers and a cable-stayed construction method minimizes its impact on the picturesque natural surroundings, with the viaduct almost seeming to float above the Tarn River Gorge. As with all projects like these, though, the construction of the Millau Viaduct was approved because of the need to improve transportation in the region, as prior to its completion the area experienced severe traffic congestion. The viaduct has since become an essential part of the A75 autoroute, providing a high-speed connection between Paris and the Mediterranean coast, effectively bypassing Millau and reducing travel times significantly. Seen as a slick solution to the problem, the viaduct has received a number of awards for its design and functionality, including the prestigious Outstanding Structure Award from the International Association for Bridge and Structural Engineering. And in recent years, it's even become a visitor attraction in its own right, with people wanting to see its architectural beauty and the panoramic views from the structure for themselves. Number 3. Otoyol 5, Turkey. Otoyol 5, also known as the O5 or Ankara-Izmir motorway, is a highway in Turkey that stretches approximately 196 miles to connect the country's capital, Ankara, with the coastal city of Izmir. This modern infrastructure project provided a vital transportation link between these two major Turkish cities and has brought the country closer together. Construction of the O5 began in the early 2000s with the aim of creating a high-quality multi-lane motorway that would provide efficient transportation and reduce travel times. It was designed to cover diverse terrains, including plains, mountains, and valleys, which required construction of numerous tunnels, viaducts, and bridges. It's the tunnels in particular that are the most impressive, such as the Manisa-Sambun-Cubeli Tunnel, which is the longest, measuring over 4 miles long. Officially opening in 2019, Otoyol 5 is now central to Turkey's transportation infrastructure, having slashed the travel times between all the destinations along its course. With design features like multiple lanes, service area, rest stops, and state-of-the-art traffic management systems, it ensures a safer and more efficient journey. It too has encouraged a huge amount of development alongside it too, with towns with easy connections to the highway experiencing some major economic growth. With plans to incorporate technology and charging stations along the O5, it will become the backbone of Turkey's transportation network for years to come, with several other projects already being planned that will intersect with it to more fully connect the country to the rest of Europe. Number 2. The Lærdal Tunnel, Norway. The Lærdal Tunnel, located in Norway, is one of the longest road tunnels in the world, measuring around 15.2 miles long. It crosses the scenic mountains of Norway and connects the towns of Lærdal and Årland. It's a clever and critical transportation link in a country that's characterized by rugged terrain and challenging weather. The main idea behind this tunnel was to provide a reliable year-round transportation route between the eastern and western parts of the country. Before its construction, travelers had to navigate treacherous mountains and ferry crossings, which were often subject to weather-related disruptions. Building such a long road tunnel, though, doesn't come without its problems, especially when it comes to safety, and designers had to incorporate a series of features to keep drivers as stimulated as possible while traveling through a monotonous tunnel. There are then things like lighting, ventilation, and emergency shelters, but it's also divided into 4 sections, with each section designed differently to change what you're looking at, and in some cases having caverns adorned with artistic lighting installations. Amazingly, it only took around 4 years to complete and an estimated cost of around $113 million, even though it needed tunnel boring machines, drilling rigs, and the removal of approximately 50 million cubic feet of rock. The end result is a wonderfully smooth tunnel that offers a pleasant journey across the route and has majorly transformed the lives of all those that it serves because of how much easier it is for them to travel, no matter the time of year. Number 1. The Ray, Georgia, United States. The Ray, located in the state of Georgia in the United States, is an innovative and sustainable transportation corridor that's attempting to promote eco-friendly transportation, renewable energy, and smart infrastructure. It's named after Ray C. Anderson, a renowned environmentalist and founder of the Interface Inc. The Ray is a living laboratory and a model for sustainable transportation solutions. Stretching along a 16-mile section of Interstate 85 in southwestern Georgia, the Ray serves as a test bed for cutting-edge tech and sustainability initiatives. It encompasses a variety of projects and aimed at reducing environmental impact of transportation and improving the overall quality of life for communities in the region. One of the central goals of the Ray's mission is to promote renewable energy generation. And to do this, the corridor features a solar-powered electric vehicle charging station equipped with solar panels that harness energy from the sun to charge the EVs. Another groundbreaking feature of the Ray is the implementation of the Wattway solar road technology, which involves the installation of solar panels directly onto the road's surface. These solar panels generate electricity while also providing a durable and safe driving surface, and could be the kind of innovative approach that'll be needed to reach a true carbon-free future for transport. The Ray is also testing new ideas for road safety and innovation, so it's been equipped with smart road infrastructure too, including solar-powered road studs and interactive pavement markers that enhance visibility and safety for drivers. By collaborating with the vehicle manufacturers and tech companies, it's a testing site for connected and autonomous vehicles as well, and offers a real-world environment for the development and validation of these techs, which are expected to enhance road safety and reduce traffic congestion. By giving a space for these ideas to prove that they're viable on a larger scale, the Ray should help fast-track various techs to being rolled out on a national or even international basis, much quicker than would have otherwise been possible. But it's not just about technology. It has established pollinator-friendly habitats and planted native vegetation along the highway to provide essential foraging and nesting resources for pollinators, such as bees and butterflies, contributing to biodiversity conservation too. It also will further reduce the overall impact of transport infrastructure. I'll see you guys next time. Watch our binge-watching playlist if you'd like to watch all of our most popular top 15 videos. Grab a drink, grab a snack, and get ready to binge. Thank you to our channel members.